So when we're talking about probability, we have a bunch of special rules. And so the first rule we're going to talk about here is our rule of addition. So our special rule of addition is as follows. The probability of A or B happening in the context of A and B being mutually exclusive, right? So we have to put that over here, that events A and B are mutually exclusive. Event A cannot happen when event B happens, and so on and so forth, right? When they are mutually exclusive, the probability of one or the other event happening is simply the sum of the individual probability of either event. So this is this situation where all of my events are separate and distinct from one another. So they don't overlap, and they're therefore mutually exclusive. So let's do an example here. So we are told that there is a machine that fills plastic bags with a mixture of beans, broccoli, and other vegetables. Most of the bags contain the correct weight, but because of the variation in the size of beans and other vegetable, a package might be underweight or overweight. So we are given the following information. So we have three categories of weight, right? We have underweight. We have right on target, satisfactory, just right. And then we have overweight. And each one of these weights happening is an event. And so we would say this is event A, B, and C. We're just randomly assigning letters to the situations that are happening, right? If it's underweight, we're going to call that an event A happening. If it's satisfactory weight, event B. If it's overweight, event C. We're then told some information. We're told the number of packages that are underweight. We find that there's 100 of them. The number of packages that are satisfactory are 3,600, and the number of packages that are overweight is 300. So we know by adding all of these up that there were a total of 4,000 packages filled in the last month. And so now we need to figure out what the probability of each one of these events occurring is. So the probability of occurrence, what we're going to do is we're going to take this 100 number and divide it by the total number of events. So we have 100 divided by 4,000. Over here we have 3,600 divided by 4,000. And then over here we have 300 divided by 4,000. So we end up with 0.025 here. We end up with 0.900 here, and we end up with 0.075 here. Now, if we've done this correctly, when we add all of these up, 0.9 plus 0.075 plus 0.025 is going to give me a 1.00 flat number. So if we ask ourselves, what's the probability that the package is going to be either underweight or overweight, what are we really asking for? We're asking for the probability of event A or C happening. And so in order to calculate this, since they are mutually exclusive, a bag cannot be satisfactory and underweight. A bag cannot be underweight and overweight. A bag cannot be satisfactory and overweight, right? They're all mutually exclusive. The Venn diagrams do not overlap in terms of these three events. And so we're going to use our special rule of addition, and we're just going to add the probability of A to the probability of C in order to get our probability of A or C. So the probability of A we know is 0.025, and the probability of C we know is 0.075. So we're going to add these two up, and we're going to end up with 0.100. So what are some other ways we could write this, right? This could be we could say it's 10%. And then the other way we could say this in probability, right? If it's 10%, then it's also a 1 to 9. 1 to 9 is another way we can represent that. All meaning the same thing here. So the next rule that we have when we're looking at probability is the complement rule. The complement rule, let's just go back to white for a second. So the complement rule is used to determine the probability of an event that happens by subtracting the probability of an event not happening. So the complement rule states that the probability of event A happening is equal to 1 minus the probability of, and then we use a tilde to represent the notion of not. So this tilde, it's going to mean not. And so the other way that we could figure out what is the probability of the packages being, erroneous, being either overweight or underweight, right? The other way we could do this is we could say the probability of A or C is equal to 1 minus the probability of B. So this is going to equal 1 minus, and we know the probability of B is 0.9. And so this is going to give us a probability of defects at 10%, 0.1, or 1 to 9.